Hello, ladies and gentlemen. This is Mr. Perez here with Module 5, Lesson 1, the area of parallelograms through rectangle facts. This is a little bit different. We haven't been here before, me conducting lessons through videos. So I want to stop and think about some of the ways that you need to work through these if you choose to. First of all, there will be moments where I ask you to stop and think. I'm going to give a little bit of a pause in the video, but not very long. So when I say pause and think, I want you to literally pause the video, stop and think about the problem for a moment, and then you may resume the video as soon as your thinking is done. There will be other times where I ask you to do the problems, write your answer, write the work down. Once again, I'll give about a 5-second pause in the video. Definitely not enough time for you to finish the work. So what you need to do is to actually pause the video, try it out for yourself, and then resume the video, and you can see as I complete it. It's really important that you stop and think, and you stop to write, and you stop to work, because trying to work out yourself, even if you're stuck or confused, is always going to be better than just watching me do it through a video. So I really recommend that you take my suggestions and you pause the video whenever I say to stop and think, stop, do your work, or however I phrase it. It's always a good idea to pause the video, try it out yourself. Let's start with this opening exercise, and here we go with the stop and think. I want you to stop, think, and write down what are the names of these shapes. Stop, think, write. Okay, hopefully you did pause the video and you're back. So let's talk about the first shape here. The first shape is, obviously it's a triangle, but let's be even more specific. What type of triangle is it? Hopefully you're thinking, or you even said out loud, this is a right triangle. And we know that this is a right triangle because there is this little box down here, and this signifies there is a right angle. And if you recall, right angle is 90 degrees, and a 90-degree right angle in a triangle makes the triangle a right triangle. Next shape. Here we have what is known as a parallelogram. Parallelograms have parallel sides. So as you can see, the top and the bottom are parallel. Sorry about that. And the other sides are also parallel. So they're parallel, meaning they go in the same direction. If we were to draw them forever, they would never intersect. They would always be the same distance apart from each other. Next shape. Here, if we want to be really specific, we can call this an isosceles triangle. We can call it an equilateral triangle. This is your basic run-of-the-mill triangle. Right? It's also an acute triangle because all angles are acute, meaning they are less than 90 degrees. All angles are less than 90 degrees. Next shape, here we have a rectangle. This is a rectangle. I know that these four corners are right angles. I know that opposite sides are parallel, just like a parallelogram, except it's not leaning over. So the top and the bottom are parallel, meaning they run in the same direction. And then, of course, the left and the right are also parallel. Another thing about rectangles, the top and the bottom will always be the same length. And then the sides will always be the same length as well. This is a rectangle. And we have one final shape. This shape is known as the trapezoid. Trapezoid is a quadrilateral, meaning it has 4 sides. What makes it different than a rectangle and a parallelogram is that not all 4 sides are parallel. As you can see, the top and the bottom are parallel to each other. The top and the bottom are going in the exact same direction. They will never touch. However, the left and the right hand sides are not the same. They're not the same size. They're also not parallel. Also, as you can see, the top and the bottom are not the same size. This is a trapezoid. Well, how did you do? We have these 5 shapes. Hopefully you named more than one correct. How many did you name correct? All right, well, here I am on the next section. This is the exercise page on page 1. Find the area of each parallelogram below. Note that the figures are not drawn to scale. So what's interesting about a parallelogram, and I really want to highlight this fact, that parallelograms, I mentioned already, are basically like a rectangle that's been turned on its side. So I want you to really imagine this. If this is a perfectly drawn parallelogram, I admit it's not, but if it was, if we were to cut off the parallelogram, any location, really, what shape do I end up with? Now I admit this is not the best of drawings. Actually, this works really well when you get a parallelogram and you cut it. You actually physically cut the paper, move it around. But we get a rectangle. I move the piece around, I get a rectangle. Now what's interesting about this is that we know how to find the area of a rectangle. The area of a rectangle is found by simply taking the length, so we'll call this entire shape here, that's the length, and then calling this the width, and if we were to multiply the length times the width, we would get the area. Well, the same thing is true for a parallelogram because they really are the same shape. So if I were to take the length of a parallelogram, we'll call this also L, and then I were to take the height of a parallelogram. Now, this is where it gets tricky because the height of the parallelogram has to be straight up. If you're going to measure how tall you are, you would actually stand up nice and straight and tall. You would not lean over. You would not be leaning over. Look, this is leaning over. I don't want to measure this as the height or the width or whatever measure of the parallelogram. I don't want to call that. I want to call actually this straight up and down. This is what I'm going to call the height of a parallelogram. This is the height. That's how tall it is. If it's standing on its feet, that's how tall it is. So I want to call that, I'll call that the width. Right? So if I'm multiplying the length and the width, sometimes you call it the base and the height. That's how I'm going to find the area of a parallelogram. So I look at question A, and question A gives me 3 numbers. They're trying to fool me. They're trying to trick me. First of all, I want to acknowledge that they gave me this 5 centimeter piece here. I don't care about that. Not necessary, because what I need in order to find the area of a parallelogram, what I need, area equals base times height, or length times width, however you want to see it, but base times height. What is the base of this parallelogram? The base is 6 centimeters. What is the height of this parallelogram? Remember, height, see what color did I use? I used this color. Height goes straight up and down. And notice they even put this little box here, which means it forms a 90-degree angle with the base. If the base is 6 and the height forms a right angle, and that length of little length there is 4 centimeters. That means the height is 4 centimeters. So what does that mean for the area? It means that I multiply 6 times 4, and I multiply centimeters times centimeters, and I get 24 centimeters squared. Take a look at question B. Question B, what is the base of this parallelogram? What is the height of this parallelogram? If you know the base and you know the height, all you have to do is multiply them in order to get the area. The base is 25 meters. The height is 8 meters. That means that the area is 25 times 8. It's actually 200 meters times meters is meters squared. Go ahead. I want you to try it yourself. Go ahead and try letter C all by yourself. Remember, when I ask you to try the work, go ahead, pause it, work it out on your paper, see if you get it, and then come back here, hit play, and hopefully you have the correct answer. All right, hopefully you tried it. I know that the formula for area of a parallelogram is base times height. I know the base is 12 feet. I know the height is 7 feet. I could ignore that 11.5. Don't really need it for this problem. All I gotta do is know what 12 times 7 is, and that is 84. So the answer, 84 square feet, 84 feet squared. That is my answer. Did you get it right? If you got it right, good job. If you missed it, did you use that 11.5? Ask yourself, why is 11.5 not supposed to be used here? If you didn't use 11.5, you just made a calculation error. Be aware that calculators are okay to use in this type of work. All right, here we go on number 2, very next page. We're not going to actually complete these directions. The directions ask us to draw the height of each parallelogram. We will do that. However, the next part of the directions we are going to skip. It asks us to measure and to find the area of each parallelogram. I'm not going to measure, mostly because I'm doing this on an iPad and the size doesn't stay the same. I can make it bigger, smaller. So to figure out its base and its height, it just depends on whether you print it out, you're doing this on a screen. It just doesn't work. So the first part of this actually illustrates a really good point. Draw and label the height of each parallelogram. I mentioned the base and the height are the two important pieces of a parallelogram. If I am to identify the base, and the base is already identified for us, it is right here. That is the base. What is the height of this parallelogram? Stop and think. The height of this parallelogram, you may have remembered, I just mentioned this a moment ago, is always going to be perpendicular to the base. In other words, it's going to form a 90-degree angle with the base. So I'm going to pick just a random point on the base, and I'm going to draw a line going straight up. So this line going straight up, it forms a 90-degree angle with the base. Therefore, that represents the height of the parallelogram. Very simple. A is done. I created a height going straight up and down. And remember, the height of a parallelogram is not the side of the parallelogram. This is not the height. Don't fall into the trap. Question B, same idea. If we know the base, here's the base. Go ahead, stop and draw the height of this parallelogram. All right, hopefully you remembered that it is always going to be perpendicular to the base. I can go anywhere on the base, and here I'm going to go here, and I'm going to do as best I can to draw a nice straight line straight up and down. There is some technology assistance there that made it easier for me. And this is my height. There we go. Nice straight up and down. That's the height. Remember, it is not the side of the parallelogram. Question C. This is the one that confuses students every year, and I want to see if you guys can get this one on your own. So recall, we need to identify the base. There's the base. The base is labeled for us. Now, what is the height? Where is the height of this parallelogram? I want you to stop and think, and I want you to do your best. Take a moment, pause this video long enough to go ahead and draw what you think is the height of this parallelogram. Right, hopefully you took my advice and you actually did pause. This one, it's kind of a trick because I've mentioned that the base and the height have to be perpendicular. They have to form that perfect 90-degree angle. Basically, they have to look like that perfect T shape, upside down T in this case. They have to look like that. But if I were to do that anywhere on this base, let's say I started here and I were to draw a line straight up, then you might be tempted to stop your line right there. That's not the height because the parallelogram is much taller than that. And in fact, you can see the parallelogram goes up to this height. So I need to draw a line that is perpendicular to that green line. However, it needs to be straight up and down so that it reaches the height of it. This is one of my favorite ways to think about it. If I were to imagine the base just continuing, like on that purple dotted line, then I could actually draw the height going from there to the top corner. I'll start from the top, just going nice and straight and matching up with where that base reaches. It still forms a 90-degree angle with that base. It's just not necessarily touching the base. So this length here, starting from here down to here, that does represent the height of the parallelogram. It just so happens to be outside of it. All right, let's move it along. Question number 3. If the area of a parallelogram is 35 over 42 centimeters squared and the height is 1/7 of a centimeter, write an equation that relates the height, base, and area of the parallelogram. Solve the equation. All right, this is one of those where I know in class you guys would probably struggle with this. I have a good feeling that you guys would struggle with this. I would really want to encourage you to try this one. So I'm going to. I want you guys to stop, think about this problem for a minute or two. Really think about what does it take to find the area of a parallelogram. I want you to pause the video, but then I'm going to come back and give you some hints. And then I want you to pause the video again and keep going. So if you get stuck, you can count on some hints. Go ahead and try it out. Okay, hopefully you did try it out. Hopefully you did pause the video. Here is hint number 1. In order to find the area of a parallelogram, I need to identify its base and multiply that information by its height. Now, some of that information is given inside of this problem, and some of the information is missing. I want you to try to use this formula and what you know about equations to try to solve this problem. Go ahead, pause me again, and try it out on your own. All right, once again, I hope you tried this. Well, hey, take a look here. The area is given to me. They're telling me the area. They told me the area is 35 over 42. I'm going to stick with just the numbers and ignore the units for now. 35 over 42. And I know that the area is equal to whatever the base is multiplied by whatever the height is. Do I know the base? Now, rereading the problem, they don't ever tell me what the base is, so I still don't know what the base is. That's the question. What is the base? But I do know what the height is. The height is 1/7. All right, great. I'm going to have you guys pause the video again, and I want you to see if you can figure out a way to solve this problem. Okay, so the big question here is, what is B? What times 1/7 equals 35 over 42? Well, what you guys do know about equations is you want to isolate the variable. So I'm going to divide both sides by 1/7. I'm going to divide both sides by 1/7. I'm going to do some work over here. What we end up getting is 35 over 42 divided by, or in other words, as we see in the fraction, 35 over 42, what I mean by that is we have a fraction over here, 35 over 42 over 1/7. That's just division. So it's just this, right? Remember on this side, on the right-hand side of the equation, these just cancel out. So we have B, and now we just got to figure out the other side to get my answer. So all I got to do is really think about, how do I divide fractions? KFC. Keep, flip, change. Keep, flip, change. So I'm going to go ahead and work that out, and that's going to give me my answer. So I'm going to do some cross canceling. So 7 goes into 42 6 times, so that's 1 and that's 6. And then that leads me to a much easier problem. 35 times 1 is 35, and 6 times 1 is 6. So the answer really is 35 over 6. 35 over 6, simple as that. Remember, we could switch this around by using some division into an improper fraction, into a mixed number. It is currently an improper fraction. So I know it goes in 5 times, and then I know I'm going to get a remainder of 5, which means that the final answer is 5 and 5/6. And since we're talking about centimeters, the answer is 5 and 5/6 centimeters. So that was a little bit more of a challenging question, but I really feel if you take it step by step and you remember your skills from earlier in the year, I think that's one that you guys can nail down. All right, let's read this lesson summary. The formula to calculate the area of a parallelogram is A equals BH, where B represents the base and H represents the height of the parallelogram. Remember, the height of a parallelogram is the line segment perpendicular to the base. Perpendicular to the base. If this is the base, perpendicular forms that nice perfect T shape with the 90-degree angle. Perpendicular to the base. The height is usually drawn from a vertex that is opposite the base. So a vertex that is opposite the base. So taking a look at this one as an example, question number 2, a vertex opposite the base. Here is a vertex, it's a corner on the top, and I would draw it straight down. It says usually, in my examples earlier, I don't think I did that, but it's a good idea to do that, especially when you get a problem like number 1, or I guess number 1 is not a good example, but if you were to draw it outside, you would draw it like this. You imagine that line going out, and it does form a 90-degree angle there. So the height is not going to be one of the sides. Do not be tricked. The height is perpendicular to the base. Now, go ahead and try the homework. I know I wrote it down somewhere, what I expect you guys to do. I think I assigned 1 through 7 odd. Might be all 1 through 9 odd. Go ahead and take a look at Google Classroom and you will get the correct recommendation of the assignment. Good luck, and hopefully I can give you this earlier tomorrow so that you have an opportunity to work on it during the day. Good luck and be safe, 6th graders.